Okay, our next presentation will be LimeSDR as an enabler for satellite TV transmissions. Our speaker, David Crump, has been a licensed amateur radio for 47 years. Well, and has been transmitting and receiving amateur television for much of that time. He home-built first commercial satellite TV receiver system in 1986. After a career serving worldwide as a pilot in the Royal Air Force, he is now retired and is project leader of the British Amateur Television Club's Portsdown TV transmitter project. He also has been one of the architects of the band plan of the web spectrum monitor used to enable shared use of the QO100 wideband amateur TV transponder on the Es'hail-2 Geo-satellite satellite. So thanks and welcome, David.
Thanks, Alberto. Good morning, all. Right, I'm going to talk about the LimeSDR as an enabler for satellite TV transmissions. And these are the topics I'm going to go through. My background, I started off, got my amateur license in the 70s anyway. And soon after getting my license, I was lucky enough to come across at a flea market that camera on the left, which is a valve TV camera. It had a sync pulse generator that used about 20 valves to divide by 625 to get 625 lines. But that started me off on amateur TV. And the sort of pictures we used to exchange in those days are the ones seen on the right there, pretty grainy, black and white analog TV pictures. I maintained my hobby, but after university, I seemed to be enjoying this flying stuff, and I went off and joined the Royal Air Force and was lucky enough to fly Jaguar and Tornado, so I'm more at home that side of the runway than this side, possibly. However, through my travels with the Air Force, I managed to keep the hobby going and became involved with the British Amateur Television Club. Our aim is to promote the use of amateur TV, so just like amateur radio, except we do TV. We've got about 1,400 members currently worldwide. We run non-profit. We run some events in the UK mainly and stands at ham radio rallies all over the place, trying to get more people interested in amateur TV. We do a quarterly magazine that has lots of good stuff in it. We do, here's an advert, offer free membership to students. So anybody in full-time education can get free membership and get all the information. Another thing we do is we sponsor projects and facilities. Now, the projects I'm going to talk about is the Portsdown project to transmit digital amateur TV. And I'll mention one of the facilities we sponsor later as well. Now, amateur TV has always followed broadcast standards. I must admit, my first transmissions were on 405 line TV, which preceded 625. We then went on to 625 line System I or System B, G, as it's adopted in Europe. And then amateurs started using frequency modulation TV as used for the early satellite downlinks. But a number of our members worked in the industry, and one of them managed to get hold of some ex-broadcast digital TV coding equipment. We did some early tests with this in 2002, and we found it had real potential using this DVB-S mode that's meant for satellite comms for terrestrial use. Multipath wasn't such an issue as the professionals thought it was. And in 2002, we were regularly making contacts over 70-odd kilometers. However, digital did bring with it its own challenges. You know, it was new complexity. Most of the members of the British Amateur TV Club had been doing amplitude modulated TV, which is fairly easy. You know, just amplify the video signal, make it large enough, pop it on the screen grid of a valve transmitter, or on a little bit adjust something in your transistor transmit chain, or FM TV, even easier. But digital TV was more complex, and the early digital TV setups, you can see the block diagram there on the left, there wasn't a lot of surplus equipment available, and what was available was large. This is some of the smaller early equipment. You can see that's taking up, well, it's the coder and the modulator there are 5U in a rack. My first coder was 6U, and I didn't need the electric heater on in the room when I was running it. You know, it really took a lot of power. However, never wants to stand still. We started looking at how we could get around this, how we could improve things. We found this device here, a USB device that would code video into MPEG-2. And we could write some software to recode that into a transport stream. And the first efforts on this actually used the Centronics printer port on the computer, and we toggled the lines on that to generate the INQ streams. Filtered those, low-pass filtered, and applied them to an IQ modulator at around 70 megs, then mixed them up to our desired transmit frequency. Started with big PCs, and then we started to migrate to, well, rather than using the printer output, we can use these FTDI modules that everybody's familiar with, the USB modules, to get digital output easily out of a PC. And having done that, we could perhaps migrate to smaller computers. And one I built used this dual-core A9 Android TV stick running Linux. And that worked very well. However, then came along the Raspberry Pi. How many of you here have got a Raspberry Pi sat on the shelf or doing something? Plenty of them, yeah. We really got on board at the Raspberry Pi 3 stage, where you've got an onboard H.264 video encoder in hardware. So we can do the really hard bit of getting the image into a small digital bit stream in hardware. It's got a very nice digital camera and some good fast GPIO outputs that we can toggle. And there were some touch screens available. You know, good market there for touchscreens. Evereast F5OEO actually takes most of the credit for this project. He developed an application called RPI DATV. Now this will do two things. It will either toggle one of those GPIO outputs at the transmitted frequency and modulate it with QPSK. How he does that, I have no idea, but it works. Or you can take INQ off of those GPIO outputs. And he came up with something that was touchscreen controlled. The only problem for us was all the documentation was in an article written in a French magazine, which wasn't so good for our members because, you know, the English are well known for their mastery of other languages. And it really needed somebody who knew Linux to install it and make it work. So a friend of mine and I sat down and thought, well, how can we get this project to the stage where the people who used to do analog AM TV will do digital TV? And the answer was, we were going to take this and package it for general use. We designed some hardware to do the IQ modulation, and we even supplied some PCBs and some of the modulator PCBs made up as a club. Again, all non-profit, all the profits went back into providing this stuff to make digital and amateur television accessible to the masses. It did rely on an external filter modulator board, some custom hardware. I wouldn't call it an SDR. No, we put RF in, put INQ in, and you get the frequency you want out the end modulated. And we had although we provide printed circuit boards for those, not many of our members were that comfortable with doing the surface mount required, the surface mount soldering. Some of the filter chips, particularly that one there, were very challenging to them. So we arranged to have some made up. In block diagram, we tried to make as much of the system as possible available from commercial off-the-shelf components. So video comes in through a commercial dongle, sound comes in through a USB dongle, and we use a Pi camera. Plug into a Raspberry Pi 3. You then need something to sit on top of the Raspberry Pi to connect all the GPIO connections, so we sold a printed circuit board to do that. And we identified a touchscreen on eBay that did the job. We use an ADF 4351 synthesizer, again from eBay, and straight into that filter modulator board. Then you get an output, and you can control it from this touchscreen here in our first version. And that worked very well for a couple of years, but then along came LimeSDR, and people thought, perhaps we could start using this. And Everest modified the software published by NVIDIA in LimeSDR Toolbox, such that we could, rather than using the hardware filter modulator, we could just use a LimeSDR on the end for transmit. And it was an ideal solution to simplify the system. By then, the touchscreen menu had got a lot more complex or capable. And we end up with something that you can see demoed upstairs later. Touchscreen, we've now migrated to a 7-inch touchscreen. We can do updates over the internet so that when a new capability becomes available, the users don't have to ever go anywhere near the command line. They press a couple of buttons, check for update. It pings over the internet. If there's an update there, it says, do they want to load it, yes or no? Don't force it down their throats. Just make things easy for the users. Touchscreen only control. Most users of this system don't go anywhere near the command line. They just use the touchscreen to control their SDR. Variety of transmission modes there. And the LimeSDR, of course, gives us this massive frequency range of 50 to 3.4 gigs. And I have used it out on 3.4 gigs directly. Works well. So that was all looking very good for terrestrial communications, but then along comes this satellite. Now, I was lucky enough to be involved in some of the planning for amateur use of a couple of transponders on the Qatari geostationary satellite Es'hail-2. And those transponders are 2.4 gigs up, 10.4 gigs down. There are two on there. One's narrowband, about 250 to 300 kilohertz wide, used for single sideband and FM. And the other one that I'm really interested in is about 8 megs wide, got soft skirts on it, so probably 9, and is a wideband transponder for TV. But, you know, in the early days of satellites, they built Goonhilly with 30-meter aerials to get up to geostationary satellites. You have to think about power budget and link budget on this thing. The gain of it was such that if you wanted to fill the whole transponder at full power, you needed about 100 watts into a 2.4 meter dish. Now that isn't something a normal amateur is going to be able to get away with. His wife is going to get very grumpy. However, if you go down to about 2 megs of bandwidth, so only use a quarter of the transponder, you can use a 1.2 meter dish with 100 watts, or maybe even you can play the games on dish size versus power there. So for QO100, we had been able, using LimeSDR and a special receiver, to reduce the bandwidth of our digital TV transmissions. And in 333 kilosymbols, which takes up about 450 kilohertz, you can get a decent TV picture across. So you can use a 1.2 meter offset dish. Now most of us can get away with one of those in our garden. Use an ex-UMTS PA, probably about 30 or 40 watts. Drive it with a LimeSDR and a Portsdown, and you've got a consumer TV transmission system. To receive the satellite, you can use the standard LMB. You know, the downlink is in 10495, which is only 200 megs below the bottom end of a standard satellite LMB that you would use for Sky. Trouble is, of course, the IF comes out at 745 megs, so you can't use a standard satellite receiver after it, but you can use a custom satellite receiver like the Mini Tuner, and I can show you one of those upstairs, or an SDR like LimeSDR, RTL FM, whatever, to look at it. You can see how much activity is on QR100 by looking at the web spectrum monitor. Now this isn't a web SDR in the traditional sense, it's only a spectrum monitor. And if you look at the signals on there, you'll see a lot of them are very narrow. You know, we were talking earlier about 3 2 meg wide signals within the transponder. You can get a usable picture up there in 125 kilosymbols, so you're into 20 odd signals for this satellite. And given that it covers over a third of the Earth's population, you know, it's a fairly limited resource for that many people. On the right-hand side there is the chat window that's on the same window, same web page as the web SDR. And that has enabled a lot of development with people trying various new things and getting reports and ideas about how to improve them. And it's provided a very good forum for this open source discussion and development of software for SDR. Okay, I'll leave the videos to the end of the results, but I just want to talk about why Portsdown and LimeSDR. The main thing is it hides the complexities of an SDR, all the stuff that we've heard other people talk about this morning, the command line and GNU radio and so on, from the user. It just puts it behind a touchscreen. And there's no PC or network required. Touchscreen control, you can select your frequency from the touchscreen, or you can actually, on the keyboard button, just enter your frequency. You can adjust the configuration. And you can do the complex things that you need to do with SDRs without going to the command line. You can update the firmware on your Lime. Some of you might know both the Pluto and the Lime need calibration and tend to put out a big transmit spike when they calibrate. Well, you can turn the calibration on and off from the touch screen. So you can do it once, store the settings, and never need to calibrate again. So we're trying very much there to hide all the complexities from the users, but make the facilities available so that they can change things if they want to. Hardware-wise, you can use a small touchscreen, large touchscreen, Raspberry Pi 3 or 3B or 3B Plus. The 4, unfortunately, is not currently compatible. And on the SDR side, you know, a LimeSDR Mini or USB, or it also works on a LimeNet Micro. We're not standing still on this one. There is some custom firmware available for a LimeSDR, which enables you just to send it the data for your QPSK over the USB link, not the IQ values that you want. That means you can run the USB link a lot faster, or you can get a lot more throughput through the USB link, and you take the processor load off your poor old Raspberry Pi that's working quite hard. So you can increase your symbol rate and do upsampling. I mentioned video coding. Compressing our video down to smaller bandwidths enables you to use lower power, means we can get more people onto the satellite. When we've been looking at using the Jetson Nano from NVIDIA, which has a hardware H.265 encoder, to do that encoding. So we take that away from the Raspberry Pi, but we still control it from the touchscreen on the Raspberry Pi to hide all the complexity from the user. To back that up, we've had a wiki which has all the information on it, and we've identified where people need to go and buy the equipment from, or if it's not purchasable, we can sell it through our club shop. It's all open source on both the hardware and the software side. You know, if somebody else wanted to build the hardware, we're not worried. Our aim is to get more people using radios on the air, transmitting television. Community development groups and support groups, all very ad hoc and informal, like the rest of the open source movement, but really works for us. So before I come on to the video, the demonstrations upstairs, we've got a LimeNet Micro running this software, transmitting, and a mini tuner receiver. And we've also got a demonstration of the custom firmware up there. And using a in fact, we've this morning got working a LimeNet Micro receiving it with other software. But there are all sorts of games you can play there using the Lime for transmit and for receive. I won't hang around on that slide because that'll be in the handout, I hope, or on the website, I hope, at the end, which is all the references, including the WebSDR there. I would just like to show you the. I'll just pull up the video. Hang on, and then I shall take questions. So using a wrong. Sorry. Here we go. Using H.265, that is the sort of quality you can get in 500 kilohertz. And this was recorded off air from the satellite the night before last. You can see this guy's just, he's just adjusting some settings there. But you can see the quality of that picture. That's a 720p picture transmitted in less than 500 kilohertz on the satellite. And he's using the Jetson Nano controlled by AE Portsdown, transmitting through the LimeSDR Mini. And I'll leave it at that. Thank you for your attention.
Questions?
Why did you choose DVB-S for terrestrial transmission? Why not DVB-T?
We could generate DVB-S using this crude hardware. DVB-T was very expensive to produce, and we couldn't get any equipment to produce it easily. And we can also reduce the bandwidth of DVB-S down to very small, 100 kilohertz, whereas DVB-T, there's 8 megs, there's 6 megs, there's 2 megs, there's 1 meg, but it is not so flexible.
Okay. And what's the delay from image acquisition to transmission?
It depends on your encoding chain. Through the satellite, the whole link is at best about 5 seconds. At worst, some people 10 or 15 if they're using slower encoders. But that comes down to the quality of the encoder and decoder.
Okay.
Just a silly question,
Yeah.
but I was not aware of this kind of amateur TV clubs. What kind of transmission they broadcast?
Well, we have a joke within the club that a lot of the people in the club are the British Amateur Television Transmitting Club. We don't care what picture we transmit or what the quality is, we just want to transmit a picture. It tends to be shots of the latest thing you have built. It is not content in the normal sense. It is point a camera at something and get the picture across. But yeah, good question.
Thanks very much.
Thank you. Thank you.
Okay, thanks again.